So ladies and gentlemen, welcome to our mathematics revision class, and in this class I'm just going to look at part 4 of mathematics revision. Should be part 4 or part 5. I think this has to be part 4. Yeah, but please just make sure that you go through all the parts and make sure that you also go through all the tutorial videos I have covered from introduction up to polynomials and also other topics. So please make sure that you do so. Like I said, we are going to look at Math 1120, and this was written in 2023. So we have 3 questions there. We have the first question, which is A, then we have B, we have C. Like always, I don't just go direct and solve things, but I'll first identify the topic so that I can alert my mind and make it know what I'm about to start doing. So this one is coming from inequalities. This is coming from inequalities. Then this one is also, this is equations. Yeah, this is equations. This is coming from equations, which is a very easy question. It's a very easy question if you check up. And then this one is coming from graphs of rational function. This one is coming from rational function. Okay, it's a very nice topic, and for this one please make sure that you watch a video on our channel. I've already done that. This one is coming from calculus, which is the limit. And then this one is coming from partial fractions. Check out the video on partial fractions. It's already available on our channel. Then this one is coming from calculus integration. Due to the wideness of calculus, so this one I'll do it tomorrow. With you guys. I'll also marry it with I think this one and this one, or this one and that one, depending on how fast I'll go. But I'll either marry them or I'll just leave 2 of them. So let's quickly get started and start with the first one, which is having 5 marks. Wow, this is free mark from this question. This has to be your free mark. This also has to be your free mark. Then this one also has to be your free mark. The only ones you can have challenges is the calculus, guys, but I hope you'll be able to catch up. So I'll write my solution, and in this solution I have been given the inequality, which is x plus 2 should be greater than 12 over x plus 3. Okay, and this is our I. One rule in inequalities, when you're doing inequality, one of the rules that you need to understand is do not cross multiply. Rule number 1 for inequalities: do not cross multiply. So since we have been guided that we are not supposed to cross multiply, so this guy will go to the other side. So we are going to have x plus 2 minus 12 over x plus 3 minus 12 over x plus 3 is greater than 0. So once we understand that, the next thing is we need to work out these guys. Okay, we can easily work out these guys. So how can we easily work out these guys? We can change this one into a fraction. We can also change that one into a fraction. Then we find the lowest common denominator, and then we say is greater than 0. So the lowest common denominator there, it is x plus 3. Okay, then you say 1 into that, it is that, so x times that. So since I'm explaining, and for the first timers, I'll write it the way it's supposed to be written, but for those who have done much mathematics and a lot of solvings, you don't need to write certain stages. Then this one will be plus, I'll say 2 times 1 into that, it is that, so that times 2, so I'll write x plus 3. Then I'll say minus 12, because x plus 3 into x plus 3 is simply 1. 1 times negative 12 is simply equal to negative 12. So from there, we can now multiply everything. X times x, it is x squared. Then x times that, it is plus 3x. Then we can say 2 times that, it's going to be 2x. Then 2 times 3 is going to be 6, and then negative 12 there, then over x plus 3, and then is greater than 0. After we are done with that information which we have illustrated there, the only thing is to collect like terms. So x squared is alone, so you get x squared, and then 3x plus 2x is simply equal to 5x. Okay, and then 6 minus 12 is equal to negative 6 over, and then x plus 3, and then it's greater than 0. When you reach that particular point, what you have to do now is to factorize what is on top. Factorize what is on top. If it is a polynomial, factorize it. So this is where mathematics tends to be relatable, or depending on other parts. So as we go further, any part of mathematics might need you to apply the concept of polynomials, might apply the concept of factorizing a quadratic equation, and many other stuffs. But one thing that you have to understand is mathematics is something that is like a building, so it has certain foundations. So for this one, you factorize it. You say product, sum, and factor. Product, sum, and factor. The product is negative 6. The sum is 5. For sure, the factors will be 2 and 3. 2 and 3. I think that can't work. Those two factors are not working, so I have to try out other factors. The other factor we can try out is 6 and 1, of which 1 has to be a negative, so that when we say 6 minus 5 minus 1 is going to be 5. And then also when we say 6 times negative 1, it's also going to give us negative 6. After we do that, since the coefficients of x squared is a 1, so I won't do that next step, but I'll just easily say x plus 6 open bracket x minus 1 close bracket over x plus 3, and then is greater than 0. When you reach this point, ladies and gentlemen, when you reach this point, your next thing that you have to do is to simply look for the critical points. Okay, the next thing that you have to look for is what we normally call the critical points, the CPs. Okay, so what are your critical points in this particular case? In this particular case, your critical point, you're just going to equate those factors in the numerator and that expression on the denominator, you equate them to 0. So I'll start with that. So I'll say x plus 6 is equal to 0. So x is equal to negative 6. So this is the first critical point. This is the first critical point. Then another critical point I'll get from that one, it will be x minus 1. I'll equate it to 0. So x is simply equal to 1. And the last critical point I'll get from that one, it's x plus 3 is equal to 0. So x is simply equal to negative 3. So I have 3 critical points. I have 3 critical points. In this particular case, I have 3 critical points. Now, since I'm having these 3 critical points, I have to make sure that I arrange them according to how big they are. Okay, so from that, I am going to correct my data. Remember, I have x is equal to negative 6, x is equal to negative 3, and x is equal to 1. So if you look at this, one thing that you need to understand is that negative 6 is the lowest amongst them all. Then here's my advice. There are so many ways in which you can solve inequalities, but the one of using the timetable, it seems to be the easiest and somehow the shortest amongst them all. So in such a way, I'll advise you to all use the table method. So you guys should make sure that you are used with the table method. So this is how you draw the table. So you are going to start with the first part, then you're going to have the second, and then you are going to have that part, and if possible you can also add another part like that, depending on the number of critical points that you have. So in our case, we have 3 critical points. Then you draw like that. Okay, so once you draw this table, you are going to put your critical points. The first critical point will be there, negative 6, followed by the other one, negative 3, and followed by 1. Where students make mistakes, it's where I'm going to illustrate. A lot of students, they do make mistakes on that particular part. So here you put x should be less than negative 6, then there you're going to put negative 6 should be less than x, and then x should be less than negative 3. There you're going to say negative 3 should be less than x, and x should be less than 1, and then the last part, x should be greater than what? 1. So if you write something like this, what you're just saying is that you are trying out all the numbers in the universe. So if you talk about all the numbers in the universe, we are simply talking about the negative infinity to positive infinity. We are simply talking about negative infinity to positive infinity. So once you write this table, your next thing is to put these guys which were on top. So we had these guys on top and that guy down there. So you put x plus 6, then you are going to put x plus 3, then you are going to put x minus 1. So these are the three guys you are going to put in the box which is on the last side. Okay, then if you want, you can put the whole equation in that box, but sometimes personally I don't put it. So once you do that, what you have to do now is to test. Here this table is just helps us to test. So let's quickly test. So if you get a number which is less than -6 and you put it there, so let's say -7. So -7 plus 6, it's a negative number which is -1. So you just put negative. You get the same -7, you put it there, it's going to be a negative there. You get the same -7, you put it there, it's going to be a negative there. Then you get a number, which is between -6 and 3. Let's say we talk of a number which is between -6 and 3. So a number which is between -6 and -3 is -5. The number which is between -6 and -3 is -5. -5 there, it's going to give you positive. -5 there, it's going to give you negative. -5 there, it's going to give you negative. Once you are done with that, you're going to get a number in between -3 and 1. So you can get a 0. 0 there is positive. A 0 there is positive. 0 there it's negative. You get a number bigger than 1. You can get 100 or 1000 or 10 billion, whichever number which is greater than 1. So if you put it there, it's going to be positive. You put it there, it's going to be positive. You put it there, it's still going to be positive. Doing this is not enough because you are remaining with the final stage, which you have to apply your grade 2 work which you were taught when you were at primary school. So negative times negative is positive. Positive times negative, it's negative. Positive times negative, it's negative. Negative times negative, it's positive. Then positive times negative, it's negative. And then positive times positive times positive is simply positive. Look again. You have reached at the green part. So the green signs are the ones that are giving you the answer. The green guys are the ones which are going to tell you what you have to select. It's not everything that you have to select as your answers. Now, the question you have to ask yourself is, how are you going to pick, or which one is the right one? So the answer to that question, it normally lies in this particular equation. So you go and utilize this symbol here. Utilize this symbol. So this symbol is telling you something. Since this symbol is pointing toward the right, it's telling you pick what is positive. Pick what is positive. Okay, since it's pointing toward the right hand side. So from there you can pick what is positive. So you have this one, and you also have the other one here. So you have those two guys as the guys who are positive. So from here you can come up with a set. You can come up with a set. So let me just erase that that table. So this is what you can say. You can say solution. So for the solution in this particular case, if I was you, I can write as follows. I can say -6 less than x less than -3, and then you can put union x is greater than what, 1. Or you can rewrite this expression as follows. You just, since this is just a less than without an equal to, so it will be open -6 comma that one -3 open, then union, like that. Okay, union, then you can say 1, not -1, 1 comma positive infinity, and then it is open. For those who have challenges on how to change the set builder notation to the interval notation, go back and check the video on sets, and specifically you can check out the videos which is sets of numbers. Yeah, sets of numbers. So under sets of numbers, I have taught, like, there are more than 6 videos. There are sets of numbers. I've made about 6 videos so far, but I'll make more. Okay, is there any question so far before I move on? Any question? Feel free to ask. Yes, I can see someone with a hand up. You can just unmute yourself and ask a question. Okay.
Yes, kindly explain again, like for the signs on the table, like just how to make the signs at the start. Like x is less than -6, and those things on top, like how we're supposed to go about. Kindly explain.
Okay, right, no problem on that. There is this part here. This part, every inequality, when you are putting them on the table, the arrangement is just the same. The arrangement is just the same. Whether in the inequality there is greater than, or there is less than, or there is anything, the signs for the guy I have put in that blue highlighted part, they are just the same, like that. Unless if there is something that is having a positive or negative, but even if there is something having a positive or negative, you can change it when you reach that particular point. I think we'll do a question of that kind later on. Then what is on top, which is these guys. So for these guys, these are critical points. The critical points, we got them from on top here. We got this guy here, we worked it out, it gave us -6. Then this one there, we worked it out, it gave us 1, and then 3, it gave us -3 by equating them to 0. Your only task, which you might need my explanation, is how to arrange them. So you start from the smallest one, the same way they appear on the number line. So the smallest one you start, then the one which follows, like in this case, since there are 3 of them, so you put the one which follows there. Then the biggest one has to be at the far end, the way I've put them. But the arrangement in that blue line, they are just the same, like that. Is that okay? The reason why the arrangement is like this, we are throwing all the numbers in the universe. Is that okay, or there is a part you need my help? Okay, I can see her.
Yes, the thing is, okay, one we're using x is less than -6, and then someone else will use greater than 1. Like, can you explain just the sign there? Like, can we also use x is greater than -6?
Okay. Okay, I think you haven't gotten my point, but I'll try to re-explain it in the way you might understand. So this is a number line. Okay, this is the number line here. So if this is our number line, the way it is, the number line is having all the numbers in the universe from -infinity to +infinity. If these are the numbers in the universe, we need to try them out. Everything, every part of a number line, we need to try out because we want to know where the answers are. So this is the demarcation as well. I'll start with -6. If I put -6 there, okay, -6 there, and then for this -6, since it's the critical point, I'm going to try out numbers from -6 going towards the negative side. That's why it is less than. Numbers from -6 going to the negative side. That's why it is the smallest and it is on the farthest point. And that's the reason why there is a less than there. A less than is telling you go towards the negative side. So we are trying out numbers that are there here. Those are the numbers we are trying out. -6 is not part of the answer because in the equation there is that that's greater than, which doesn't have an equal to. Then the other guy which you haven't gotten the point is in between here, -6 and the -3 here. So if you pick that part, you need to understand that for this particular part here, -6 is less than x is, which is x is less than -3. Here, if you pick a number in between here, let's say -5, -5 is less than -3, but -5 is greater than -6. That's what this simply mean. If x is -5, this means that -5 is automatically greater than -6, but it is less than -3. So this -5 is standing for all the numbers in between -6 and the -3. That's why you are having something like that. Then you are having a 1 there. A 1, once again, when you talk of a 1, we are having another part of it. We are having two parts of it. The first part, it is this one, which is connecting it with the -3, so that particular part. Then the last part of -1, it is the one which is going up to +infinity, the one which is going up to +infinity, which is this guy here going this side. That's why there is a greater than, which is telling you going toward the right hand side. This simply means that you are trying out numbers which are bigger than 1 up to +infinity. So for more information about these, you need to visit sets of numbers. Go and check the videos. There are about 6 of them on sets of numbers. So if you're not understanding this particular part, then you did not understand sets of numbers. But for your question, this is how I can explain it to you. Is there any question, or is it clear now? Is it clear?
Clear. It's clear. Thank you.
You're welcome. So that's it for that particular question. So let me quickly go to the equation. So for the equation, this is very easy. This work is very easy for you guys. Is equal to x, like that. So if you look at that, it's either you can take the x to the other side, or if you want, you can cross multiply, depending on what is okay with you. Okay, but for inequalities you do not cross multiply, but for equations you can cross multiply. So what we are going to do, we are going to say over 1, then we cross multiply. So this will be -2 is equal to x, open bracket, 1 minus x, close bracket. So -2 is equal to x minus x squared. These guys will go to the other side. I don't like the x squared having a negative, so this will go to the other side. So it will be x squared minus x plus, minus 2, which is equal to what? 0. So from this part, I just feel this was a free mark. This was a free mark. It was not even supposed to have 3. So from there you can say products, product sum and factor, product sum and factor. So the product is -2, the sum is -1, then the what, the factor, it is 2 and 1, of which -2 is supposed to have a negative. Since this has a coefficient of 1, I'm not going to stress. I'm going to say x minus 2 and then x plus 1 is equal to 0. For some tutors, they will tell you to say, since the coefficient is 1, so just take these guys, just change the signs for that guy. Yes, they are correct. Yes, you are right. But if you haven't written this step, you are not going to get the full marks, because in mathematics there is a method mark. So for this question, this part is having a 1 mark. So you equate these guys now to 0. So x minus 2 will be equal to 0, and the x plus 1 will be equal to 0. So x is equal to 2 and x is equal to -1. So these are the final solutions. The only part which someone might make a mistake or might lose marks, it is only this part where you have to write that expression, because if you don't write it, then you are going to lose all your marks. Okay, if we are done with this guy, I think I can now go to the next guy here. I'm going to go to the next guy there. I am kindly asking, at the end of this class, please go and watch my video on rational function. There is a video on rational function. I'm kindly asking you, after this class, go and watch that video. I've explained most of the stuffs. So here mostly what happens is you have to know how to sketch a graph of a radical function and a graph of a rational function. So what are you supposed to do? Very interesting question. So f of x is equal to 1 over 1 minus x squared. F of x is equal to 1 over 1 minus x squared there. So from here, what you can do is that you are going to find the domain. Okay, the domain is the one which will help you, or you are going to find the asymptote. That's why I'm asking, go and watch that video, because I've gone much in detail for that one. So we'll start with the vertical asymptotes. We'll start with the vertical asymptotes. I'm not going to go in details in this solving, because there is a video which you guys are supposed to go and watch. So the vertical asymptote, you just get the denominator there. So you're going to say 1 minus x squared is not supposed to be equal to 0, because this what I've written is how you write the domain. Okay, this is how you write the domain. So if you want, you can state the domain. Okay, let me pick it up from there. I feel I have to re-explain this so that people will be able to get the point. Then there you say domain is equal to x such that negative x squared should not be equal to negative 1, such that x is a member of real numbers. So go and check that video. I'm sure there are about 2 or 3 of them. So domain is simply equal to x such that x is not supposed to be, this will be times negative 1 times negative 1, so that one will be positive. So you're going to have positive or negative 1, then such that x is a member of real numbers. So therefore the vertical asymptote is simply equal to x is equal to 1 and x is equal to negative 1. That means that the curve is not cutting those two parts. Then the other part which you have to know is the horizontal asymptote. Okay, the horizontal asymptote here, for you to basically have much information about the horizontal asymptote, go and watch the video on how to find the inverse of a rational function. The inverse of the rational function. The inverse of a rational function is what becomes the horizontal asymptote, such that you have to find the inverse of this particular guy. But if you look at the definition of a rational function, we do avoid to have a 0 down there, isn't it? We do avoid to have a 0 down there. So if you look at this, you have to understand that this guy here will never be equal to 0. This guy here will never be equal to 0. So the horizontal asymptote is just y is equal to what? 0. Y is equal to 0. Now, once you have these guys, this is where now people's minds get confused a bit here, but I'm going to make things simple for you guys. Let me make things simple for you, and so that you'll be able to remember. So the v asymptote is x is equal to 1 and x is equal to negative 1. then the horizontal asymptote, there is horizontal asymptote is y is equal to 0. With this information, you can easily work out your graph like that. So you have the x component and your y component, your x component and your y component. Then your next thing which you are supposed to indicate on this graph, it is your asymptote. So that's your -1 and a 1 there. So when you do that, you have to draw the vertical lines which we are calling the asymptote. So you're going to draw like that, going like that down, meaning the curve or the graph will never cut this part. The curve or the graph will never cut this part. So this is how it's supposed to be, like this. Okay, once you put these guys here, your next thing is you to try out how the graph is behaving. Okay, how the graph is behaving. So remember, we have numbers which are this side and numbers which are that side. Okay, so I'll start with this part. So let's say I get two numbers. Okay, I think this I'll just be explaining it. So I have a function which is f of x is equal to 1 over 1 minus x squared. So if you take, let's say, taking x is equal to, you get a number which is less than -5. Let's say you get -5 there. If you put -5 there, f of -5 is simply going to be 1 over 1 minus -5 squared is 25, and this will give you 1 over -24. 1 over -24. Then if you get another number, let's say taking x is equal to -2. If you take x is equal to -2, your equation, which is that, it's going to be 1 over -3. 1 over -3. So this number here, this number is small. Okay, this number is small, and then this other number is what? Is big. Okay, this number is small and this other number is a little bit big. Okay, so with that in mind, what you have to know is that since y is a little bit in front, is a little bit that side, and this one is a little bit big in nature, but because it's a negative, okay, because it's a negative, this number is greater than that one. So 1 over -24 is greater than 1 over -3. So the graph here will simply behave in that particular way. It's not going to touch the asymptote. Why is it not going to touch the asymptote? The reason is simple. The x-axis, it is the horizontal asymptote, and then the y-axis, it is the x-axis, it is the horizontal asymptote, since that's where y is 0. Okay, so you do the same thing with this side. So when you try out the same thing this side, I'll give you as an assignment, the curve will surely come out like that. Okay, the curve will surely come out like that. So this is how it will work out. If you get a 5, this side, it's going to be 1 over 1 minus 25. Actually, to give you the same thing, since this is square there, it will give you the same thing. Okay, since this is squared, it will give you the same thing. Okay, so this is how it will behave down there. You haven't gotten any positive, so it can't appear on top this side, it can't appear this side. Now with this in mind, we can try out numbers in between there. But before we try out numbers in between there, we need to find out at which particular point is this guy cutting the y-axis. Where is the y-axis being cut? So this one, you say f of 0 is equal to 1 over 1 minus 0 squared. So for you to know where the y-axis is being cut is when x is equal to 0. So y is equal to 1 over 1 and the answer is simply 1. So the 1 can be there. So the 1 can be there, and then you have to indicate that 1. So that's why it's cutting this particular curve. So 1 is there. So if you put a number which is close to -1, okay, if you get a number, let's say -0.5, okay, -0.5 squared. What is -0.5 squared? It won't exceed a 1. Okay, so 0.5 squared, it won't exceed a 1 because that's 0.25. so since it's 0.25, that number is a little bit greater than what you can have. Okay, because 1 here, it's producing a 0, isn't it? So here, if you put a 0.25 there, you put a 0.25, it's going to give you 1 over 1 minus 0.25. Automatically, this number is bigger than a 0 you're getting there. So this side, it will go this direction up, and then this side again, you get a number like 0.25. There you got a -0.25. it gave you a number bigger than that. So that means that here it is just going up. Okay, so this side is going up like that without touching the asymptote, and that side is going upward without touching the asymptote. Okay, so that's how easily you can work out these guys there. So you just go there, and then there you go like that without touching the asymptote. So your marks are normally hiding in terms of how you show it, but remember that if you do not show these coordinates on your number line, then you are 100% going to get less marks. You're going to get less marks for not indicating the coordinate. So this is your y-axis and that is your x-axis. So with this information which we have, I can quickly look at the last guy. Then I'll allow you guys to ask me questions. So let's say we have lim x is approaching 1 positive, and then we have f of x, which is 1 over 1 minus x squared. Okay, 1 minus x squared. Okay, so x is approaching 1. Okay, for this one, the reason why they gave you this graph is for you to use it for the next question, okay? For you to use this graph from the what? For you to use this graph for you to find that particular question. So look and observe. The y-axis, it has the positive infinity from there and the negative infinity from here. It has positive infinity and the negative infinity. That's why this guy was having a 1 mark. So there it has the negative infinity. So from the question, they are telling you approach f of x. Approach f of x, of which you are approaching 1 as your limit. Approach 1 from the positive side. So this positive here is telling you from the positive side. So if I was to be approaching this curve or this, if I was to be approaching this curve or this graph from the positive side, so as I am going this side here, okay, as I am going this side, ladies and gentlemen, follow me very well. As I am going this side, approaching this one, okay, because they are telling me from the positive side, and then you approach 1 as your limit. As I am going this side, ladies and gentlemen, what I'm finding is that this y is becoming negative infinity. The y is becoming negative infinity. Look where this graph is going. It's going like that. It's going like that. Okay, it's going like that. So as I am approaching this guy from the positive side, this y is becoming what? Negative infinity. So the answer here was simply negative infinity. Just like that. Just like that. Nothing hard, nothing to even think. It's just for you to analyze. So for you to fully understand how I have approached this graph, you need to understand the introduction of calculus, specifically the limits. There are about 2 graphs there. There are about 2 graphs there which you need to understand. And with time, I'm going to give that introduction. So guys, at this particular point, I'll allow you guys to ask questions if you have questions. Then due to time, I'll do it tomorrow. I'll do it tomorrow, as I'll be tackling math 11 and math 1100. And then for those who might have questions after the class, you are free to WhatsApp me on those lines. But for you guys who are in class and you have questions, you are free to ask right now.